Welcome to AI Native Micromonopoly. Today, we are going to explore how to build the unmagical code that turns fragile AI into autonomous production engines. Standard chatbot setups often fail under real-world conditions. While a toy demo might work well with instant API responses and constant human babysitting, production reality is chaotic. To run a high-revenue operation, your AI cannot require constant oversight while you sleep. It must handle client delivery and operations on its own. So, what exactly is the harness? It is the unmagical code you write around your AI model. This scaffolding gives the engine hands, manages its budget, handles rate limits, and ensures it keeps running autonomously. A well-engineered harness solves real-world failures by tackling the four critical pillars of autonomy: loops, memory, errors, and validation. Unlike a naive agent that relies on infinite loops, prompt stuffing, and blind trust, a harnessed agent uses deterministic cutoffs, context budgeting, resilient error handling, and skeptical verification. Let's look at the first pillar, loops. A confused, naive agent can easily get caught in an infinite feedback loop, like clicking the same broken link, burning thousands of dollars in API tokens in minutes. To prevent this threat, a proper harness acts as a breaker. It wraps execution in a rigid for loop with a strict step ceiling, such as a 10-turn limit. If it hits that limit, it cuts off execution, logs the exact state, and sends an alert. For memory, you must treat your context window as a financial and speed budget, not a bottomless bucket. Prompt stuffing, shoving massive code bases or databases into every turn, acts like a bursting pipe that degrades model speed and adherence. Instead, the harness acts as a precision valve through context compaction. It trims histories and feeds the model only the exact, precise signals it needs for the current turn. On the unhappy path, production-grade engines must survive when things break. If an API throws a 429 rate limit error, the harness seamlessly catches it, parses the wait time, sleeps, and retries. If the model fumbles and outputs malformed JSON, the harness intercepts the syntax error before failure and feeds it back into a correction loop, telling the model to fix the JSON and retry. Because models can lie or hallucinate success, a robust harness requires skeptical verification and isolation. When an AI claims it clicked a checkout button, a verification gate forces a deterministic check against the DOM or API state before returning a success signal. Furthermore, an isolation barrier ensures the model never handles complex authentication directly. The harness handles auth programmatically. Depending on your business, you can build this architecture in two ways. Code first involves writing custom scaffolding in Node or Python, ideal if the unique value of your business is the actual logic of the agent. Alternatively, configure first leverages pre-built runtime harnesses like MindStudio or Microsoft Agent Framework, allowing you to visually map business logic without reinventing the underlying plumbing. Ultimately, shifting your focus from low-leverage prompt tweaking to engineering resilient harnesses unlocks massive operational capacity. With a proper harness managing the system, one solo founder can manage dozens of specialized, highly reliable digital workers, achieving the output of an entire traditional agency.